For this Greenbelt challenge, we want to see if the percentage of patient satisfaction is different between males versus females. It is a one-to-one structure and we're comparing proportions, so we will use the two-proportion test and the file will be patient data. Our alternative hypothesis is set up that percentage of patient sat for males is not equal to females. The null hypothesis is then set up that males equal females when it comes to percentage of patient satisfaction. Let's open our file and get started. This exercise is very similar to the demonstration, except instead of looking at patient satisfaction by office, we're going to see if there's any difference by gender. Therefore, we will focus again on column P and also column M. In case you didn't see the demonstration, the way we got the data in column P is this. If in column I, the respondent rated the survey between a 4 and a 5, column P will show up as satisfied. If in column I, the respondent registered a 1, 2, or 3 type of response, then column P will show up as not satisfied. Like in the demonstration, we'll start off by going to an easy pivot table. This is a lot better than trying to manually count this. We go to Sigma Excel, Graphical Tools, Easy Pivot, Entire Table Next. SAT discrete becomes our X1, gender becomes the X2. We uncheck the charts, but we do want grand totals. So when we hit OK, we automatically get this nice analysis. It tells us that we had 45 females in the study, 30 of which were satisfied. We had 55 males in the study, and 37 of those were satisfied. We will either memorize or write those numbers off onto the side. We then proceed to Sigma Excel, Stat Tools, Basic Stat Templates, Two Proportion Test, and we will make sample 1 male because that's the way our alternative hypothesis was set up. So the total number of males surveyed was 55. The total number of females surveyed was 45. We then go to the event, which would be a satisfied patient. 37 males were satisfied, and 30 of the females were satisfied. Immediately we get our results. Like all our other analyses, we start with the p-value. Here it is 1. That is the highest p-value you can possibly get. Remember, P stands for probability. What is the probability you would be wrong if you rejected the null? This is telling us there would be a 100% chance of you being wrong if you rejected the null. Thus, because we have this high p-value, we fail to reject the null. And if you scroll over to the right, you can see that is the same conclusion the software wants you to come up with. Now let's scroll back and let's focus on the actual results. Sample 1 is male, sample 2 is female. The sample proportion is telling us that 67.3% of males were satisfied and 66.7% of females were satisfied in the sample. The difference between them is 0.6%. If you look down at the confidence interval, it's telling you that if you were to go out and survey all males in the practice and all females in the practice, the difference in the population proportion, not the sample proportion, but the difference in the population proportion of all males versus all females would be somewhere in the range of minus 17.2% to a positive 18.8%. Because 0 is in that confidence interval, it means that there may be no difference between the population scores of male versus female. There definitely was a difference in the sample scores, but if we looked at all males versus all females, the true difference is somewhere between minus 17 to positive 18% between those, and 0's in that range, therefore failed to reject the null. We could not detect a statistically significant difference based on gender in the population percentages of patient satisfaction. Hopefully you got those same answers. Let's go back to the material and learn some new things.